Okay, good morning. Welcome to
AwesomeMath101.
AwesomeMath101. So we are talking still about modular arithmetic and modular inverses today, and we have this theorem from our book, which seems a little abstract. In mod m, a number r has an inverse if and only if the greatest common divisor of m and r is 1. Okay, so we're going to look at mod 35. In other words, m equals 35.
Yep.
Okay, so let's look at, does 2 have an inverse, mod 35?
Well,
So does 2 have an inverse?
well, 35 is just 7 times 5.
Okay.
They have no greatest common divisor other than 1, so 2 doesn't have an inverse.
Okay, so let's find it then. So our theorem, because 2 and 35 have no common divisor other than 1,
It should have an inverse.
it should have an inverse. So what is the inverse of 2
Well,
in mod
it
35?
should be 18, because 18 times 2 is 36.
Aha, 2 times 18 is congruent to 1 mod 35. Haha. Okay, very good. High five. Does 5 have an inverse?
Well, I don't think it should have an inverse, because 35 is 7 times 5,
Okay.
and the greatest common divisor would be 5.
Aha, greatest common divisor of 5 and 35 is 5. So 5 will not have an inverse. 5 times nothing is congruent to 1 mod 5.
Because 5 times 7 is 35, and then one less than that would be 30. It would be 30 mod 35,
Yeah,
and then above that would be 5, so.
yeah, it wouldn't work.
No.
Okay. How about, does 3 have an inverse?
3 should have an inverse. It would be equal to 12. 3 times 12 is 36.
Ah, okay. So 3, the greatest common divisor of 3 and 35 is
1.
1. So, and you notice that 3 times 12 is congruent to 1
Mod 35.
mod 35. Okay, now are you ready for a super challenge?
Yep.
Okay. Do you want a super challenge or an ultra
An
challenge?
ultra challenge.
Does 20 have an inverse?
It doesn't.
Why not?
Because it's 4 times 5.
Alright,
And 35 is 5 times 7.
okay,
So the greatest common divisor is 5.
alright.
And it only works if the greatest common divisor is 1.
Only works if the greatest common divisor is 1.
So it doesn't have an inverse.
Doesn't have an inverse. No inverse. Right. Good job. That's how we use that theorem. And that's going to be important when we're looking for inverses to help us solve problems.
Yeah.
Okay?